Good morning, chemistry students. In this video lesson, we are going to be continuing our discussion on Standard 2B. Specifically, we are talking about how we can use density to identify substances. Density, of course, is a physical property of matter that we can actually use to identify a pure or a pure substance. We'll leave it at that. So what is density? Well, density is a measurement of mass per volume. So in science, we have scientific units, SI units, and these are the units that we actually use to take measurements. So mass is traditionally measured in grams. Though you can see kilograms, we just don't tend to use kilograms very often in chemistry because it's a very large unit. Volume has two common measurements in chemistry. The first one is milliliters. We would use that for liquid volume. So milliliters or actual liters. Again, we don't tend to use liters too terribly often because it is a rather large volume. Another unit for volume that we will use in chemistry is centimeters cubed, or cm to the third power. This is for solid volume. It's length times width times height. The larger version of centimeters cubed is meters cubed. Again, we don't tend to see those larger versions too terribly often in chemistry because we tend to deal with smaller measurements. Now, density is a physical property of a substance, and it does not change for any substance at a set temperature. So it is temperature dependent, and some substances, as the temperature increases, we'll notice that our density decreases. And if we go through a phase change, we have a very significant decrease in density overall. So once we take and put our mass over volume together, we end up with complex units. The units of density are these little fraction units. So anytime for now, when we see a fraction unit, you're going to want to think density. And the two most common ones we will see are grams per milliliter or grams per centimeter cubed. So how do we calculate density? Well, density is mass over volume. For those of you who are not the best at algebra, there is a great little cheat that allows you to do density calculations very, very easily. It's called the magic triangle. So if I take a triangle and I draw an uppercase T in it, it separates it into three parts. And if we fill in our density equation, so if we notice that my density equation, I'm dividing. So I got to show that division in my triangle. So I'm going to have mass over volume, which means, which means my density is going to go in the other spot. The usefulness of this triangle, it allows you to actually do calculations without actually having to do the algebra. You just need to plug in the numbers and solve for the remaining part of the triangle. So what this triangle tells me is that if I am trying to find volume, so volume is my unknown, volume would equal mass over density. So my volume, my milliliters, would equal my grams over my density, which is grams per milliliter. The grams end up canceling out. We are left with milliliters. This triangle also shows me that if I am trying to find mass, so again, I'm not having to do any algebra. In order to find mass, things are side by side, so that means we have to multiply mass equals density times volume. So if I take my density times my volume, I'm always going to get my mass. And of course, we have our original equation. If we're trying to find density, we can see that density is mass over volume. So if algebra is not your best friend, write this triangle in your notes and use it as you are doing your density calculations. For those of you who do want to see the algebra of it, we can actually rearrange that density equation by getting rid of the fraction bar. So we originally have density equals mass over volume. And to get that volume to disappear, we got to multiply both sides of the equation by the same thing. So I'm going to multiply both sides by volume. Well, on the right side of the equation, we end up with volume divided by volume, so it cancels out, which gives me volume times density equals mass. That's that same equation that we saw on the previous slide. Well, once I have it in this linear form, it's actually quite easy to solve for my volume. So I'm wanting to get volume by itself, which means I'm going to have to divide by the thing that's being multiplied by volume. So I got to get rid of my density. So I'm going to divide both sides of my equation by density. Now on the left side, my density cancels. And we are left with volume equals mass over density. So just using a little bit of algebra, we can see how all three of our density equations are related. Let me get the third one on the screen. Density equals mass over volume. But our magic triangle is a great tool for the students who are not quite as confident with their algebra to use. Now, the main thing to know when you are doing density calculations is you've got to be able to relate a unit to a variable. So you have to know the unit for mass. Mass is almost always grams. Again, we could see milligrams, we could see kilograms, but it's some version of grams. So volume could be milliliters, liters, centimeters cubed, or yes, meters cubed. And what that leaves us with is our density unit being a fraction. So if you're seeing a fraction for a unit, that lets you know that it is definitely density, but density is always measured in grams per milliliter, grams per liter, grams per centimeter cubed, and grams per meter cubed. Again, could see kilograms, not likely. Could see milligrams, again, not likely. So let's actually do some calculations with density, solving for density, and then using density to actually determine something else. So straight up word equations. You cannot get away from word equations in science. And there are some strategies that will help you make the math of the chemistry a little bit easier. When I am doing a word equation, I always break it up into three parts. I always write my givens, my equation, and then I go and plug in and solve for my equation. So my givens are the things that are given to me in the problem. If it is a number and a unit, it is important. If it's not a number and a unit, it might not be important. So the fact that this is a block of metal, not important. What is important is this 28.5 meters cubed. So it's a number, 28.5 meters cubed. Meters cubed, that measures volume. That is one of my units for volume. So my second number, 15.05 kilograms. Kilograms, grams measures mass. So it's asking me to find density. And on y'all's formula sheet, you are given the density equation. You are given density equals mass over volume. You can write the equation in its equation form, or you can use your magic triangle, where we have to remember that when we go to get our license, we get it from the DMV. So we're trying to solve for density. That means I don't know that part of the triangle. So in order to solve for it, I've got to divide my numbers. My triangle tells me, and my equation tells me, that I must have mass, which is 15.05 kilograms, over volume. So my units don't cancel. There's no way for them to cancel out. So we're going to end up with a fraction for a unit, which should make sense considering we are looking at density being the thing that we're trying to solve for. So I take my 15.05 and I divide it by my 28.5 and I get 0.528. The unit is kilograms per meter cubed. And I can write the calculation either way. I can write it in a flat form, or I can write it the same way that I would plug it into that triangle. Get in the habit, ladies and gentlemen, of always showing your units. We do not want naked numbers. Every number needs a unit. So 0.528 kilograms per meter cubed. General rule of thumb, keep the same number of numbers you start with. This is general, so we're not stressing too much about significant figures, but general rule of thumb, keep the same number of numbers you started with. So I started with 3 numbers. I'm going to keep 3 numbers. Dadnabbit. That moment when your clicky stuff doesn't work the way you think it's going to work. Ha, 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 ha. Okay. So this is just, again, another density problem. Pause the video, see if you can actually solve the density using our 3-part approach: givens, equation, and solve. So because my stuff is going to be a little bit glitchy, I'm just going to actually just write this one. My givens, those are the things that have numbers and units in the problem. So 45 grams. Grams measures mass. Even if that didn't tell me that, I have to know that grams equals my mass. 16 centimeters cubed. Centimeters cubed is a unit for volume. And it is asking us to find our density. So draw my little triangle, fill it in. I got to remember that I got to go to the DMV to get my license. That D always starts on that bottom left. Doing a nice, pretty clockwise circle. So we are trying to find density. Coloring in the side that I don't know lets me see that I have to have mass over volume. 45.00 grams over 16 centimeters cubed. Again, general rule of thumb, keep the same number of numbers you started with. 45 divided by 16. Handy dandy calculator gives me 2.8125. I'm just going to keep 2 numbers, 2.8. And since none of my units cancel, my remaining unit is grams per centimeter cubed. My given, equation, and solve approach to handling word problems. Alrighty, so let's look at one where I'm not trying to find density, where I'm actually trying to use density to solve for something else. Ah, snap. Actually, we will come back to that one in just a second. So where we're trying to use density to solve for something else. So that strategy will work with any type of word problem. We can use our science strategy in math. We can use math strategies typically in science. So I'm finding my numbers and the units, and they let me know what's important. So those are my givens. I'm given 900 grams. Grams, I have to know, is mass. It doesn't tell me in the problem. I have to know grams is mass, mass is grams. It's asking me to find volume. So I don't know what the volume is. But it does give me the density, 2.40 grams per milliliter. Again, that fraction unit is what lets me know that I have a density. So draw my magic triangle. And remember that when we go to get our license, we get it from the DMV. These always on that bottom left goes clockwise. So this time I'm trying to find my volume. So I'm going to shade in that volume because that's the thing I don't know. Well, my triangle tells me that I need mass over density. So volume equals mass over density. Now, you don't have to necessarily write that purple part, but I just do because I'm a little bit OCD about it. Plug the numbers into either the equation or to the triangle, and you see that you have 900 grams divided by 2.40 grams per milliliter. So notice how we have a G divided by a G. That means the grams cancel out, because when I have anything divided by itself, it is 1 and 1 disappears. So unit divided by itself basically cancels out. So I'm going to take my 900 and I'm going to divide it by 2.40. Handy dandy calculator gives me 375. Well, grams canceled out, but milliliters was left. Does milliliters measure volume? Yeah, it does. That means the math and the units support the answer. I have a unit of milliliters. That is the unit that I need for volume. All right. You guys try this one. So you're using density to find something else. So, 3-part approach. I promise this is a lifesaver. Write your givens. Write down exactly what the problem is telling you. Take those words that are really ugly and cumbersome and turn them into very short, sweet, and simple things. Oops. Centimeters cubed. So I've got a fraction for a unit. That is a density. I mean, the problem tells me it's density, but I also have to know that when I'm seeing a fraction for right now, that's its density. 52.75 centimeters cubed. Centimeters cubed is a measurement for volume. So we have density, we have volume, and it's asking us for weight. Well, weight, or weigh, is the same thing as mass for our purposes in chemistry. So we are trying to find this thing's mass. And just for giggles, those that want to actually see the algebra, we are trying to find mass. That means I need to get mass by itself. And to undo a division, we do the opposite. So the opposite of division is multiplication. So the algebra tells me that mass equals density times volume. My triangle tells me the same thing. So I can do the algebra or I can use the triangle. Either way, I'm going to get to the same place. My mass equals my volume times my density. So volume times my density. My density is 8.920 grams per centimeter cubed times 52.75 centimeter cubed. Notice I've got a centimeter cubed on the bottom of a fraction, and I have a centimeter cubed that's not in a fraction. So basically it's on top. We can imagine that it's over a 1. So I've got a centimeter on top and a centimeter on bottom. Well, that means they cancel out. So we are left with just grams. So handy dandy calculator, 8.920 times 52.75. I've got 4 numbers that I was given, so I can keep the 4 numbers. 470.5 grams is the mass of that piece of copper. All right, so our last 2 examples are kind of non-traditional examples. We're actually having to use some extra information to determine or to calculate density. So if we were in a lab, you would actually be doing a density lab experiment where you would be determining the density of objects. So picture boxes and blocks and cubes and things of that nature. Well, that means you're going to have to be taking measurements. And I don't necessarily take the measurement of the volume of a box. I actually have to calculate it. So in this particular example problem, we have a cube. And it doesn't tell me the volume of the cube. It actually tells me the measurement of the cube. It says that cube is 3 centimeters on each side. Well, in order to find density, we have to have volume. And hopefully from geometry math, you would remember that the volume of a cube or the volume of a rectangle is equal to my length times my width times my height. So 3 centimeters on each side. That is saying that I've got 3 centimeters times 3 centimeters times 3 centimeters. We're just going to pretend the zeros there. This is how we end up with a unit of cubic centimeters for volume. Because centimeters times centimeters times centimeters gives me centimeters cubed. So the volume for my box, or my cube, is 27 centimeters cubed. I can still use that whole given equation solve approach. It's just there is an extra step. We have the same givens. We're given 3 centimeters. We're given our mass. But I have to look at that equation and I have to realize that I don't have volume. So I can't find density unless I have the volume. So that's why I had to do that extra calculation. So to find my density now, I take my 25.48 grams over 27 centimeters cubed. Now, the thing I want y'all to realize in chemistry is you can end up with big numbers. You can end up with tiny numbers. The big number does not always go on top. Big number does not always go on bottom. Where the numbers go is determined by the units. So since I'm trying to find density, grams must go on top. So the density of this cube is 0.9437. Yes, I kept more than the original 2 numbers, but that's okay. Grams per centimeter cubed. So 0.94. For my general kids, not going to count off if you round. If you keep too many numbers, I'd rather you keep more numbers in your answer than you think you're supposed to. That way your answer is a little bit more precise. But general rule of thumb, round to the same number of numbers you start with. Well, 3 centimeters has 2 numbers, so we're going to keep 2 numbers. All righty, so one last example. Let's say I'm not trying to take the density of a cube or a box or a block. My density is of something that is either a liquid or something that is irregular. So like, let's say maybe I've got a handful of screws and I'm trying to identify the metal that is in the screws. Well, to take their density, I could take their density and compare it against some known values for common screws. But it's really, really hard to find the volume of a screw. I mean, length times width times height. I mean, it's kind of really, really tricky in there. Well, with something that's not regular, something that's not a cube or a rectangle, what we actually do in science is we do what's called water displacement. And we determine the volume of the object by placing it in a container of water. Of course, this assumes that it's not going to react with the water. But if I were to have my handful of screws and I were to put it in a graduated cylinder, what you would notice is that the volume of the graduated cylinder increases after I add the handful of screws. That is called water displacement. Now, sometimes in some problems, they'll tell you that the water was displaced by X amount, but other times they just tell you the beginning and the ending volume. That means you have an extra step. If we tell you the beginning and ending volumes, you're going to have to find the amount that the water was displaced in order to calculate your density or in order to do the calculations that it's asking for. So I could use water displacement to determine mass of something if I have its density. But typically we're using it to find the density of something that is unknown. We're trying to identify an unknown value. So notice the illustration, and guys and gals, you can try this at home. Get a clear glass, put some water in it, and put something in the glass that won't float. So a small rock. Don't make it too terribly small. A handful of nails, handful of screws, something you have around the house that won't float. You'll notice that the water increases as you add the object to the container. So I still use my three-part approach. I have my givens, my equation, and my solve. So in this particular problem, we are given 12.48 grams. Grams, we know, measures mass. And we are given two volumes. We're given a volume of 30 milliliters, and we're given a volume of 35 milliliters. And we are asked to find density. So to find my density, I have to have a mass over volume. Do not assume you add your numbers. You're going to have to actually possibly read the words to see what you need to do. My initial volume was 30. My volume with my object was 35. So what that means is the volume of the rock equals 35, what it ended up being, minus 30. So I use 5 milliliters as my volume. 12.48 grams divided by 5.0 milliliters. And handy dandy calculator gives me 2.496, 2.5 grams per milliliter. Again, none of the units cancel. Density should have a fraction for a unit. So my units and my calculation make sense. That is it for density and density calculations. Y'all have some practice. We're actually doing some word problems of your own. I highly encourage the three-part approach, writing the givens, the equation, and the solve. But at a bare minimum, ladies and gentlemen, bare minimum, I need to see your calculation. I have to see what you're typing into the calculator in addition to the answer. So bare minimum, I'm looking for something similar to what's in the blue box. You've got to write at least what you type into the calculator. I encourage the three-part approach. It'll make the math a lot easier for those of you who struggle with word problems. It'll help it make more sense. But when I'm looking at your practice, I'm looking to see at least, do you have the calculation? Do you have the right answer? That is all, and I hope you have a fabulous day.